So hello everyone and welcome back to the fifth lecture of the lecture series. This is Public Health. I realize that some people will still be popping in, but I like to get started on time. This series is brought to you by the Swiss School of Public Health and by ETH. My name is Emily Reeves. For those of you who don't know me already from the lecture series, then you may already have seen me somewhere, somehow through the SSPH Plus at Expo project that took place in Dubai. And if you've been following the lecture series so far, then you will have seen that a lot of the things that happened at the Expo were shown to you through this lecture series, and you got to see a few clips from YouTube of what the students were up to during their time at the Expo, and you will have also been encouraged very strongly by me, undoubtedly, to have a look at the quiz on health in all sustainable development goals, which was developed by students and faculty members of the 12 universities associated with the Swiss School of Public Health. This quiz, as always, can be accessed through the QR code that you see on the screen now. And it's easily downloadable. It is in fact part of a platform which has lots of interesting information about the Swiss School of Public Health and about the kinds of things that are offered by the Swiss School of Public Health, as well as other materials that were used via the Expo project. As of recently, I have also been including this link, which is highlighted. Given the circumstances that are going on in our world at the moment, there are many unpleasant things going on in our world today. And if any of this has affected you in any way, then please, as a student, do make the most of the resources that are available to you. There are some counselling services that are available through ETH, for example, but these kinds of counselling services are also available at almost all universities here in Switzerland. And should you require any further information, please do not hesitate to also get in contact with me. I'd be happy to help you. Before we start our sessions, as always, we tend to kind of tune in to something going on in our community. Today, I thought that it might be worthwhile sharing something other than what's been going on at the Expo, but looking forward to something that is going on here in Switzerland, which is upcoming very soon, from the 3rd to the 5th of May. Here in Switzerland, as I said, actually in Geneva. I have linked the link directly to the Geneva Health Forum here on this slide, but you can also download this QR code if you'd like to just check it out yourself. The reason why I link this is because there are many interesting topics that are quite relevant to obviously what we're discussing here, which is public health. This is the Geneva Health Forum, which brings together key actors of global health. And there are various different events that will be going on. I have listed up some of them. So just to highlight the things that are going on, there are a couple of workshops that are offered. In brackets, I kind of highlight the target group for those workshops, which can either be faculty or students. So do take a look at how you can register. The workshops are free, provided that you have registered. There are registration fees, but I believe for example, tomorrow is a deadline for getting one of the early birds, so the most economic and best deal on registering. But there are also other prices as well, and other early bird offers for students and for faculty members and so on. So please don't hesitate to go ahead and check that out and see how you may get involved in that. So without further ado, that brings us to the lecture of this week. And this week we will be hearing about the job exposure matrix, which is a fascinating way to learn about occupational and environmental exposures and their health effects. And so we're very pleased to have with us Professor Irina Guseva Canu, who's head of the academic sector at the Department of Occupational and Environmental Health at Unisanté Lausanne. So lovely to have you here. It's really a pleasure to have you come and speak to us, and we look forward to hearing more from you. Before I pass over the word to you, it's just worth mentioning that I be after the lecture is over, so that everyone is aware. There will also be a Q&A session time and a discussion time, and this session will be led by one of the students of this course, Sarah Balder. So I hand over the word now to you. Thank you very much, Professor Guseva Canu.
Thank you very much, Emily. Could you also kindly give me the sharing?
Yes, sure. I now stop sharing my slides so you can.
Super. Thank you very much. Thank you for the kind introduction, and thank you also for the possibility to give this lecture and to speak about occupational exposures and occupational health. Just to be sure, can you see my slides?
Yes.
Is it on the full screen or?
Now it is, yes.
Super. Thank you. So as Emily presented me, I am an associate professor of occupational epidemiology, and I am the only professor of occupational epidemiology in Switzerland. So I think it is my endeavor to share with you my passion and what brought me in Switzerland. And this is the occupational health and research in occupational health. Before I start, I would like to ask you, what do you know about occupational exposures? And how do you think they are different from environmental exposures? Because we've already had several talks about environmental exposures. It's quite widespread now and also very present in the media, but what do you know about it? Just let's take several minutes to openly discuss about what does it evokes for you, occupational exposure. Please take a microphone and say what comes to your mind. And don't be shy.
I think it's probably the kind of exposure to a toxin or some other chemical that is very much limited just to a specific place of work. So, for example, someone working at an asbestos mill would have much higher exposure to asbestos than someone from the general population.
It's a very right answer. Thank you, Timothy, for your courage and also for this sharing. Other ideas? Because
I also think that you can trace it back after many, many years. So, for example, for diseases like cancer, it's quite useful to have the possibility to say, okay, 30 years ago, this person was exposed to kind of environmental or so.
Thank you, Franco. So we have now two different ideas. The first idea was that it is limited to some workplaces. Another interesting idea that it could last for several years and it could have protracted effect or delayed effect several years after the exposure cessation or even if the exposure continues. Other thoughts regarding occupational exposure and environmental exposure? Could an environmental exposure be also an occupational exposure? What are the examples for this?
Yes. For example, if you look at pesticides, which could be an environmental exposure for farmers and environmental for the general public.
You mean occupational for farmers and environmental?
Yes.
Yes. Perfect. Other examples?
Also from traffic. So, for example, people working on streets and etc. Their environmental exposures from, gases from cars can also have a great impact on their health.
Super, thank you, Sarah. And what are the examples of these occupations? Because in the environmental epidemiology, the occupation is the key variable and it is highly codified. So what sort of occupations are exposed to this environmental air pollution?
I'm lost for the word right now, but what I meant, construction worker, yeah. Or
yes, true, but also policemen and also bus drivers, and also tram drivers, and many others who are working outside. So you are perfectly right. Another example, very common example from radiation. What do you have in Switzerland as a public health hazard for the general population? What about radon? Radon is a carcinogen for human, a lung carcinogen since 1982. Who is exposed occupationally to radon? What sort of occupations are the most concerned with exposure to radiation, ionizing radiation, like radon or maybe other ionizing radiation? In medical field, for example?
Oh yeah, well, radiologists.
Radiologists?
But they're actually not that much more exposed, I think, than, I mean, they have to wear this constant monitor device, but maybe occasionally if there's an accident, they will have more exposure.
It's true, but also dentists. Dentist does some diagnosis using ionizing radiation, X-rays up to now, and they are protected, but they have exposures that they could accumulate quite a lot. And also veterinary doctors who have to make diagnosis in animals. And for some very big animals like horses, for example, it could take more time than to do the same radiological exam in a human. And regarding radon, so of course we have not a lot of mining industry, but there are still occupations, for example, for mushroom cultivation in some grotto, the concentration of radon, which is emitted naturally from the Earth's crust, it could get quite important high levels, and this ionizing radiation and the products from the radioactive decay could accumulate in the respiratory tract of those people occupationally exposed to this. And we could cite a lot of examples like diesel exhaust from traffic, but also diesel exhaust in careers, in construction. We could also speak about noise, of course, a lot about different chemicals and fibers like asbestos, which was cited, but also other fibers, including very emergent materials like, for example, carbon or titanium dioxide nanoparticles, for which we don't have still the clear understanding of what health effect could be expected from this exposure. So in many cases, the same hazard, the same biological, environmental, or chemical or physical agent could be present in the general environment and could be even more concentrated in the professional or occupational environment, particularly in some of workstations, like you cited, some of them in construction, in driver's profession, etc. And we could also speak about psychosocial risk factors, the exposures to stress, for example, which are very present in professions for which we do not naturally think at the first, like teachers who are exposed to noise, to stress from classes, from the interaction with parents, for example, but also people working in finances who are stressed because of the outcomes due to their activities and investments and the risks they could take for some clients, for example. The same is in transport industry and in many, many workplaces. So what's interesting with job exposure matrices, that it is a method which allows considering all sorts of exposures, but mostly occupational exposures, because one of the key variable in job exposure matrix is a job. So the exposure will be characterized for a given job. So I invite you now to start this lecture. Thank you very much for your participation, and please don't hesitate to ask questions if something is not clear. Why do we need to assess occupational exposures? There are many reasons for it. And one of the mostly cited reasons is a regulatory reason, because every employer has a duty or an obligation to protect workers' safety and health. So people, and particularly directorates in companies and in industries, have to demonstrate the compliance with standards and recommendations regarding occupational safety and health, which I will often abbreviate as OHS, Occupational Safety and Health. The occupational exposure assessment is also often performed to inform and adapt the risk management, because in some places like metallurgy industry, for example, there are toxicants, metallic toxicants, which are present and handled, and there are associated risks which are known through toxicological studies and risk assessment studies. And we know that we could avoid this risk if there are appropriate exposure control to manage this occupational exposure risks, and to inform that they are very effective, that they are work well. People could need to assess occupational exposure to adapt their exposure control procedures. Another reason is the research in occupational safety and health, and also in occupational epidemiology, where we would like to see if there is a relationship between exposure and health effect, or between a dose of this exposure and the response regarding a particular health outcome. Are you familiar with these concepts, exposure effect relationship, dose response relationship, or should I explain it more? Just make me a sign if it works, if I can continue. Okay, so I continue. It could be also very useful to develop, for example, methods and devices to collect samples and to measure the exposure. So we could control how well the new devices measure the exposure, which is measured with traditional devices used according to standard procedures. And of course, the knowledge of occupational exposure is very important for public policy and public health decisions, because if we know the exposures, we could also try to assess the health impact of these exposures, as it was done very well for air pollution, for example, and the health impact in general population, exposure to COVID infection, and impact for the population. So we could do the same with occupational exposures. And of course, if there were some protective measures introduced for one particular canton, one of the counties, we could see if it was effective before deciding to develop this intervention or preventive measure elsewhere. And for this, we need to measure exposure before the intervention and after the intervention. Now let's see how we can measure the exposure. There are many, many ways to do it. First, we could distinguish between routine measurements of exposure in a company, in an industry, and control measurements. For this, we could use 3 different approaches. For example, if we focus on the air pollution, indoor air pollution, or in the presence of a particular toxicant, which is airborne, we could use a stationary device to sample the aerosol and then to measure the concentration of a given toxicant. Let's say it could be, for example, zinc particles in our aerosol. So we could measure the mass of the zinc in the air sample. And it is measured stationary. So for all people working in the same room where this exposure is measured, this exposure indicator would be relevant. But another way, more accurate and more personalized, is to measure the exposure in every person who is working with a toxicant or with a potentially hazardous product. And for the airborne pollutants, the best way is to measure the exposure in the breathing zone, where the person breath, and the breathing zone is defined as a sphere of 30 centimeter diameter around the nose. So, and there are some personalized devices that we could attach to the neck or to the collar and measure this exposure. And another even more precise way to measure the exposure is using biomonitoring, where we will collect biological fluids like urine or sweat or saliva or hairs, for example, and to measure the concentration of the toxicant in these fluids. It could be very often the blood. For example, for the lead, there are biological limit values in blood for the lead. And we could do it regularly every year, for example, or punctually because it was a suspicion of the accident or in an unusual event. So they could be reasons to make some controls. This is the difference between routine measurements and control, which are usually punctual. Another way to look at the exposure, as was introduced by Franco, is to consider the temporality of the exposure. And we could be interested in exposure to which we are, with which we are concerned today. This is what I called contemporary exposure assessment. So it's done in the real time. It could be prospective through the programs of exposure assessment that we could set today and that will continue in the future for several months or even several years. Or it could be retrospective. And this is very useful when we do the risk assessment, but especially when we do the research to know what are the effects of an exposure to the health. So we look what was exposure backward several months or years before. And we could collect a lot of type of data to inform the exposure assessment. And I will start with the best and the quality of our exposure assessment. And what we want to measure especially is the dose of the toxicant, which would conduct to the negative or adverse health effects. So from the best to the worst, we would start first with individual measurements through biomonitoring of the air pollutants or other toxicants, which could also penetrate through the skin, for example, through skin absorption or through ingestions when there is a contamination during the food at the workplace, for example. So in this case, we will measure directly in the body or in the body fluids the concentration of exposure that workers in the particular workplace or industry or company could bear. And the dose which will be reconstructed through these measurements could be called organ-specific burden or dose, because it's really something which represents the internal exposure incorporated or after the intake of the pollutants. And there is a term which is often used, especially in radiation epidemiology, which is a burden, which means the total amount of the toxicant which is incorporated and sequestered in the body. And one of the examples could be, for example, to measure the thyroid iodine concentration through the anthropogammametric measurements. So we could really see the burden or the charge of iodine in a gland or in an organ. And we could do the same with bones, for example, or with liver for some pollutants which have this organ specificity. The second best measurement would be to measure the concentration close to the individual using some portative devices, for example, those that we could attach in the breathing, personal breathing zone, as we mentioned here. And then we could measure the pollutants, which are not yet entered in the body, but which are potentially available for entering the body and to cause this internal exposure. So this will be called external concentration or external dose. And for example, it is the same for radiation exposure, with some dosimeters, we could measure what happens outside the body and capture this radiation on this personal dosimeters. Another way to measure external concentration would be using stationary devices. And in this case, it will be data for particular workstations or in specific industrial areas or rooms, which are shared by several workers at the same time. So it would not be a personalized dose, but a common dose shared by the same working environment. That's why we could also speaking about environmental exposure, but very, very focused as it was suggested before, to particular workstations. When we cannot measure the exposure in any of this way, we could do the expertise or the expert knowledge about another way to classify the exposure. And it could be classified in ordinal or relative way. For example, we could say, okay, this workstation is highly exposed to asbestos, like mines, for example, where asbestos was extracted from natural carriers, or some isolation works where the workstations are less exposed. So we say, okay, compared to this most exposed workstation, we have those less exposed and those unexposed. So we can classify them according to 3 classes. Or we could even say there is exposure to this product like PCB, for example, for dioxides. Yes, at this workstation, we have the potential for PCB exposure, and in those workstations, there is never such an exposure. Another way is to look for at the duration of exposure, and in this case, in the absence of data on exposure, we could consider for how long time a person worked at a particular workstation or at a particular industry, and use this quantitative variable in years usually as the exposure approximation. So we are, as you can see, we are far from the internal dose, but still it gives you some insights on the exposure. And finally, the worst case, when we don't know anything of what was presented, is to see whether the exposure is likely to be to contain some hazards or not. So it could be by job or by industry. So now you know why we measure occupational exposure and how we can measure it from the best and to the worst. And there are these 3 categories which are particularly useful to create job exposure matrices. So you can see from this slide, and you could be very disappointed saying, so finally job exposure matrices are constructed when there is nothing of very good available. And we try to do and to deal with less good data and sometimes with very poor data. But at least it gives some opportunities to answer our reasons to assess the exposure, particularly in these 2 areas, because, for example, some decisions in France to compensate an occupational diseases as occupational disease are based now on job exposure matrices. So let's now look what is a job exposure matrix. As you understood already, it is one of the methods to assess the exposure. It is based on occupational hygiene expertise. It is based on exposure measurement data, which could be available. And it also involves statistics and statistical modeling more and more. What is it, a job exposure matrix? Very simply, it is a database or a computer program which allows associating data on occupational exposure to some pollutants or some hazards with jobs. And it could look like this. So you have in this very simple database several jobs. So they are counted from 1 to 2, and it could be, for example, a truck driver, bus driver, and tram driver, or a subway driver, okay, or operator. And you could consider in this job exposure matrix one hazard, which could be, for example, PM, particulate matter exposure, or it could be all hazards present in this industry, transport industry, which could be sometimes respiratory crystalline silica, sometimes it could be noise, and sometimes it could be vibrations. And what you have in these hazards, in the intersection between exposure and job, you have the exposure estimates. And this exposure estimates could be quite different. It could be a presence of a hazard at this job, or it could be a probability of the presence of the hazards in this job. Like, for example, in bus drivers, 100% are exposed to noise. But in subway, not 100% are exposed, but only 70. So the probability here will be 0.7, for example. And it could be frequency, like every day or a part of the day or several months a year, etc. And it could also be intensity. And here we could have quantitative data from measurements of the concentration of the pollutant. So, and according to which estimates we could put inside of our job exposure matrix, depending on the available data, we could have three sorts of job exposure matrices. Qualitative, where the exposure will be just described as yes, no, or in some relative classification, which could be already called semi-quantitative job exposure matrix, when you could say, okay, 3 is a maximum, 0 is a minimum, and you could classify all the jobs for one particular hazard on this scale. Or it could be quantitative if you have quantitative measurements, usually stationary measurement, but it could be also personal measurements in the personal breathing zone, for example, like here for an airborne pollutant. Let's now see how it works, a job exposure matrix. I told you that it is quite used for the research in occupational safety and health. And occupational studies are mostly epidemiological observational studies. So we work with populations. And let's imagine that I am interested in the Swiss population, and I'd like to make a research on lung cancer and to look how the exposure to two known lung carcinogen plus zinc in the airborne particles could explain the risk of lung cancer in my study sample. So what I need, and let's imagine that I have this job exposure matrix, which is relevant for the Swiss population and the Swiss occupational conditions or working conditions, and I could use this data. How do I apply it? For applying the job exposure matrix, I need to know for every participant in my sample, its occupational history. Let's take one of these participants, which is Mr. X, and we know from the questionnaire that he filled in when accepting the participation to the study, that he worked, let's say, in the transport industry, or not, this is asbestos and silica. So what it could be like automotive or a work in a career. And he reported that he worked in job 1 for 10 years, in job 2 for 25 years, and in job 3 for 5 years. So we could merge his individual job exposure, occupational history with our job exposure matrix. And what we can get, we can calculate the cumulative exposure to this semi-quantitative assessment of respiratory crystalline silica. And we know that his cumulative exposure score, which is unitless because it's on a relative scale, is 25. So we just multiply 10 years in job 1 and 5 years in job 3, and we get this score. And we do it for everyone, so everyone would have a cumulative exposure like this. For zinc, we could go further because we have concentrations measured, and we will calculate the cumulative exposure, which will be measured as concentration multiplied by the year of exposure to every of this concentration. And this would be this cumulative exposure to zinc. And finally, for asbestos, we only have yes/no assessment. So we could work with cumulative exposure duration. And we know that the cumulative exposure to asbestos was 15 years for this person. So we do it with every individual, and to have a job exposure matrix actually offers a lot of advantages, because the only thing you need then is to know the occupational history of your participants. Now, so we saw that the exposure matrices could be quantitative, qualitative, semi-quantitative, but they could also differ according to their content in terms of jobs, how these jobs are defined. And according to this, we could distinguish 3 types of JEMs: company or plant-specific JEMs, which will only be specific for one factory. It could be specific for an industry like transport industry or mining industry or nuclear industry or chemical industry, or it could be very generic one and works for every person of our general population. So I'd like now to present you some examples of every type of job exposure matrix, and some examples where I was involved. And one of these examples is a company-specific matrix that I've constructed for a nuclear plant in France, which is an Areva-Pierlat plant, and I will explain you how I did it. And now we are doing the job exposure matrix for Parisian subway, and in this job exposure matrix, we will assess the exposure to particulate matter, PM10 and PM2.5 in the Parisian subway. So you see, this is a common environmental pollutant, but it will be really focused on Parisian subway workers. The example for the industry-specific job exposure matrices are one that you cited, plant protective products like pesticides, for example, or fungicides. And there is a JEM used for assessing the cancer risk among agricultural workers or farmers. And any exposure matrices for chemical industry. And finally, there are many matrices which do exist for general population, and there is even an inventory of all these matrices, which is called OmegaNet, and these matrices are available for general population. So, of course, they have different specificities and they have different use as well, because something which is very specific for a particular plant could not be applied to the general population or could not be extrapolated to the entire industry. So for using plant-specific matrices, we would need occupational cohorts, ideally of workers for which this JEM has been constructed. The same for industry-specific matrices. And sometimes, if there are cohorts, we could also apply them to the case control studies nested within these cohorts. And for the general population matrices, the most common use is to apply them in the case control studies, where cases are, for example, people with diagnosed cancer, and the controls are people without this diagnosis. And we could apply the JEM to assess whether controls and cases had different exposure to the pollutant of interest or to the toxicant of interest. So let's now look how we could construct a job exposure matrix. And I will use again the example, which was my PhD thesis several decades ago. It was a semi-quantitative job exposure matrix for Pierre-Latte plant. Pierre-Latte plant is situated in the south of France, in the nuclear center Tricastin, and they do a lot of stuff in the nuclear cycle, civil nuclear cycle. So they are mostly dedicated to the chemical conversion of the uranium ore and also to the enrichment. And they do some parts of the fuel fabrication of the nuclear fuel, but the most of activities are conversion and enrichment of uranium for civil purposes. However, if we look at the history of this plant, which was created in 1960, actually their activity was turned to quite a high enrichment of uranium, which since 72 up to 78 was the military degree enrichment. So this chart shows you that the activity and the exposure to the same compound, which in this case is uranium, was very different according to the time. Here, as you can see, the enrichment was up to 2%. Here it was up to 8%. Here it was 25 and 90% because it was for different activities. And then from 80s, they started chemical conversions and built a prototype plant in this Pierre-Latte center. Then they started the conversion of uranium fluorine with different isotopic content. And then they even started to make chemical conversion using depleted uranium. So, and also the cleansing activities and dismantling activities of gaseous diffusion plants, which were built for the military enrichment. So as you can see here, there are many uranium compounds, fluorides, there are also chlorides and oxides, and these are different valency of oxides and different isotopic content of this uranium. So how to assess all this in the same gem? What we've done, that we've worked with engineers from this plant, and we decided to first list all the jobs and group them into homogeneous occupational categories, which were defined according to the function, to the task, to the facility and place where this activity took place, and the time period where the exposure were deemed stable, using this all temporality since 60 to 2006 when it was done. Then we decided to consider 6 different categories of uranium compounds because we had different isotopy and different chemical formulas of the compounds. And besides, we discovered that for the chemical conversions, workers used a lot of acids, a lot of different chemical products, and many of which were known to be carcinogenic, mutagenic, or toxic for humans. So we wanted also to include these chemicals in the same gem. And we identified experts who were occupational hygienists, even those who were already retired, the engineers in charge of security and radio protection, occupational physicians, toxicologists, because they had a very, very powerful facility for biological monitoring of different radionuclides. We also invited a chemist from the same plant, nuclear physicist, dosimetrist, and epidemiologist. So together we defined the different components of the gem, and particularly the jobs and the exposures to which we would like to make the assessment. And we invited experienced workers, including half of retired workers, to get knowledge from what happened before we started our activity, especially involving military activities, and the current workers, which were still available on place. So we did this assessment, and when the exposures were defined, when the jobs were defined, they rated the exposure. And for rating the exposure, we consider the frequency of exposure to every agent for every job, and also the quantity or amount or intensity of every pollutant handled at every job. So it was estimated, then we made the Delphi approach, and we reassessed all scores in frequency and in amount of exposure, which were divergent between these experts and evaluators. And then on the second round, we validated the content and the indicators of exposure. So we had 2 exposure indicators for 22 exposure agents, which were 6 uranium compounds and 16 other chemicals. And it was done for 232 job periods, because we had 73 jobs, but we split some of them in different time periods to have periods with constant exposure. And then it was validated by an external expert from UK, for example, and from another company. And we also examined the JEM sensitivity and specificity. So I see the message in the discussion. Okay, I will. And why it doesn't work? And then we reconstructed the job exposure histories, and we could do our epidemiological studies. And for every exposure, we calculated this cumulative exposure score, where it was a product of quantity and frequency of exposure and the duration of work at every job. So we had some data for these workers before, and we knew that they are using ionizing radiation because products are radioactive, and we have 20-year dosimetry surveillance. So we had, let's say, the best estimates of exposure. And it was the external dose, which was not very high when compared to the occupational exposure limits. And as you can see, when we looked at the relative risk per 100 millisievert of this exposure for different outcomes, none of them was significantly at risk. So we demonstrated no dose-response relationship or no association. But was it a true answer? Or was it just because we used an inappropriate exposure metric? Because they worked with uranium, which is lowly radioactive in terms of external radiation emission. So our answer was probably that we should verify this thing. And particular for cardiovascular diseases, we had some increased risk, but still no dose-response relationship. So, and what was done before, and it took a lot of years, so just when we constructed the job exposure matrix, we could assess the effect of the exposure to every type of uranium on cardiovascular diseases. And as you can see, when we compared those who were exposed to natural uranium in soluble form, like type F, the risk was double. For moderately soluble uranium, the risk was a little bit less, and for insoluble, it was 1.85. But when we looked at the reprocessed uranium, we identified the different strengths of the association between exposed to these compounds and not exposed. And we could demonstrate it also by considering the exposure levels, comparing negligible exposure with moderate exposure and with strong exposure or high exposure. And as you can see, we observed the significant risk for cardiovascular diseases after strong exposure or high exposure to moderately soluble uranium from natural uranium, and especially after the exposure to slowly soluble natural uranium. And regarding the reprocessed uranium, the risk was much higher, and clearly we could demonstrate here the trend, increasing trend with decreasing solubility of uranium used. And we also observed the significant relationship just by considering the cumulative exposure duration for every type of this compound. And here again, we confirm this trend with decreasing solubility. And this, yes,
I have a question.
Yes, please.
In the statistics, the exposed versus non-exposed.
Yeah.
In the non-exposed, there is a range. So, for example, type F in the first line, there is 2 versus 1 to 4. Does that mean the non-exposed, the risk is somewhere between 1 and 4?
Yes, you are right. This is the confidence interval. It is the interval
okay, it's a confidence.
where the true value is situated, because we are always working with estimates.
Oh, okay, okay.
So compared to non-exposed, those who are exposed to this type F natural uranium have a twice risk to develop cardiovascular disease or to die.
Compared to the lower range of the confidence interval.
Yes, this
okay.
We could say it is. That's why it's not in bold, because it's like of borderline significant.
Okay.
Usually this we call significant when it is really higher than 1. Like all this. And my PhD student, 6 years later, did the same study, which was actually the case control study in the same cohort. And in his study, we could assess the internal dose after exposure to uranium to heart and to lung and to kidney, which are the free target organs for uranium intake. And as you can see, whatever the model used, just a simple model unadjusted or adjusted for all risk factors of cardiovascular diseases. And here we have the gray because it is an absorbed dose. So you can see that the excess of odds ratio is always 2, and it is always significant, whatever the adjustment used. But if you compare the results we got, so it was a very reassuring result, very important, because it's the first time that we demonstrated that uranium could be cardiotoxic, especially the reprocessed uranium. And what was amazing with this research, and especially with this comparison, that if you look at this dose, it doesn't get you indication on which uranium is more harmful. And here we could demonstrate the relationship with exposure duration and with exposure intensity, or in this quantitative, semi-quantitative classification. But we clearly show the effect of the isotopic composition of uranium, where reprocessed uranium is much more toxic for every exposure matrix. We also demonstrated the effect of the solubility of uranium, which demonstrates the inverse relationship. And for the hazard identification, and clearly here we could identify for the first time reprocessed uranium as much more toxic than the natural uranium. This research, based on this simple job exposure matrix, a semi-quantitative one, finally was much more informative than this one. For the hazard identification, for the risk assessment, the dosimetry is a gold standard. And look, we could do it 6 years earlier, so it was time and cost friendly, because the money that we needed to invest to calculate all these doses was just huge. And finally, this methodology was now was reproduced in other plants at Eurodif, gaseous diffusion plant, for example, in France, but also in UK and even in US, because the method is convenient and not difficult to use. So I have to wrap up, and I will just go very quickly to the end. And to say that we could use job exposure matrices, which are already available, especially if these are general matrices for general population or generic job exposure matrices, and there are many. The last on date was the job exposure matrix for ultrafine particles, which are a fraction of the air pollution, which seems to be quite, well, let's say more toxic than some coarse or fine particles. And the challenge that we have in the job exposure matrices use is that when in one country we have data coded with one occupation, with one classification, and another country, another national classification of occupation is used. And for example, in Switzerland, as I said here, we have the Swiss nomenclature of occupations, and worldwide, the international standard is ISCO, which means International Standardized Classification of Occupations. And there are different versions according to different revision in 1968, in 1988, and this one is the most used. So to go from one matrix, one classification to another, we need to recode the occupations, and this is very, very time consuming. And to solve this problem, because in Switzerland, we didn't have job exposure matrices, so we used some available in other countries, but we had always limitation because we use our national nomenclature of occupations. So we solved this program now by creating this software which codes the occupations in raw text and also recode the occupations from one classification to another. And it is a software done in Switzerland, funded by the Swiss Secretariat for Economy and also the Swiss Federal Office of Public Health. And it is in 4 languages, so you could use it. It is a web-based device. And the whole message is to finish is that against that I presented you that the best standard is biomonitoring, personal exposure assessment. Sometimes job exposure matrices gives very, very interesting results. The interest that they are easily constructed, that they could be used for epi studies with for a long period because they have this historical consideration of exposures over decades. It could be used in the case control studies for rare diseases. And of course, the quality of job exposure matrices highly depends on the data that we will inject to construct it. But even some semi-quantitative studies could provide interesting preliminary results based on which we would conduct further risk assessment or further research. And it is really a very useful methodology in occupational safety and health. I thank you for your attention. And I see that there is a question.
So actually, I have the pleasure to lead a small discussion right now. Thank you so much for this very interesting lecture. Because we're already quite advanced on time, I think I'll encourage everyone to now ask a question in the chat, especially the most pressing ones, or to just go ahead and unmute yourselves. Maybe I'll get started with one right away so everyone else has time to type. I would be curious, at the beginning we talked about different jobs that are particularly at risk. And I was wondering, do you think you could, are there any that might not get as much attention as they might need? So what are kind of some jobs that are at particularly high risk that might not be getting enough attention, even though they're putting themselves at high risk?
Yes, this could happen. And this is why the expertise that we will use for constructing job exposure matrices is very important. So we should really include the experts who know and who have objective knowledge of the exposures for different jobs. And the literature, the published results of exposure estimates in different occupations is often a very useful source for starting the exposure assessment. And this job exposure matrix for ultrafine particles is entirely built on the published literature. So, and for this, yes, you need to consult experts to decide how to classify some occupations, some jobs where we have less data, for interpolation, for example, but we could now also do it with Bayesian analysis, because if you have some qualitative expertise and quantitative data, you could just do modeling to interpolate what you miss in data.
Okay, thanks a lot. And then I see we have a question from Charles. He asks, are there any limitations in the use of job exposure matrices? I assume that misclassifications could occur, and this is hardly avoidable.
Yes, Charles is very right. And the misclassification bias is an issue with JEMs, because we put together different personal occupational experiences just by doing the average exposure for one occupation or for one job. So of course, for some it is more and for some it is less, and we just average this exposure. So misclassification is really an issue. And yes, it's hardly avoidable, but with sensitivity analysis, we could try to minimize it. And what we could also do is to use a score and make the exposure estimate from a JEM individualized by correcting, for example, for the use of personal protective equipments. If we have this information, we could use it. In addition, we could use additional individual data from questionnaires to make it better and more personalized, I would say.
Okay, great. So then I see we have another question from Franco asking, what are the matrices for the general population mainly based on?
They are mainly based on published data, but they could also be based on the measurements. For example, there is one very big job exposure matrix, which is called SYN-JEM, and it is for 5 lung carcinogens where the low dose exposure are of particular focus. So in this international JEM for different countries, the authors gathered all measurement data from all companies in the chemical industry where these chemicals were in use. And they even used only personal occupational exposure measurements because they have huge amount of historical measurement data. So this generic matrix is based actually on measurement data, but in most cases, it is based on literature data from the exposure assessment studies.
Okay, so if there are any more questions, I would encourage you to write them now, because I think we'll about wrap this up if there are no more questions. So I think if that's that, then thank you again, Mrs. Canu, for your lecture. And yeah, I'll hand over to Emily.
Yes, thank you very much, Sarah. Thanks so much for guiding us through the discussion time. And thank you again so much to you, Professor Guseva Canu. We really appreciated the interesting insights and talks from your background and expertise. So thank you once again. And for those of you who will continue with us and who will be joining us next week, then we have a lecture coming up for next Wednesday, which is on institutional communication during pandemic threats, insights into the WHO competency framework for infodemic management. So please do join us for that. It's going to be led by Professor Sarah Rubinelli from the Department of Health Sciences and Medicine, who is a professor of health sciences with a focus on health communication at the University of Lausanne. So do join us for that. And in the meantime, I wish you a very nice evening, and thanks once again for the fantastic lecture today.
Thank you very much. Thank you.
All the best. So then all the best, and until next week. Thank you again, Sarah. Bye all.
Bye. Thank you.